Hello, welcome to this lesson video for finding coterminal angles and then also applying that to find sine, cosine, and tangent of coterminal angles. So first of all, what the heck is a coterminal angle? That's just an angle that travels around the circle more than once. So if you remember our degrees as we go counterclockwise around the coordinate plane, we went 0 to 90 to 180 to 270, and once we went full circle, we were at 360. Okay, so coterminal angles are just going to be bigger than 360, and we want to draw them in their standard position. So here's how I think about it. If I'm trying to figure out 410 degrees, its standard position, in my mind I think about, traveling full circle, so all the way around once, and I'm at 360, and then how much extra did I go to get to 410? I went another 50 degrees. So something like this, representing 50 degrees, would be my coterminal angle in standard position. So a quick calculation would just be 410 minus 360, and that's where I would have gotten the 50 from. Okay, so let's try another one. 375. So again, I've went around 360 plus how much more? 375. 375 minus 360 would mean I went an extra 15 degrees. So that's in the first quadrant, and it's definitely closer to 0. So roughly something like that would be the standard position for 375. Let's do one more. 500. Well, let's see. 500 minus my going around once at 360 would leave me with 140 degrees. So that would put me not in the first quadrant, in the second quadrant, because 140 is between 90 and 180, and it's a little bit closer to 180 than 90. So let's see, something like that would be the standard position. So hopefully you're catching on, you're getting seeing the pattern. So if you've got your trig packet, the rest are for you to do. Here's where we're gonna pick it up though, kick it up a notch. Think about the unit circle we've been doing, but now we're gonna have coterminal angles. So the first thing you wanna do is just figure out the standard position, just like we've been doing. So that would be 510 minus, going around full circle, 360. That would leave me with 150 degrees, if I did that right in my head. Okay, so this is in which quadrant? Definitely the second quadrant, closer to 180 degrees. So roughly, something like this. So that's the standard position of the angle. But we want to find sine, so we want to make this reference triangle. We want to drop our altitude and make a right triangle. And I need to know what is the measure of this angle right there. Well, that angle is formed from this x-axis, which is equivalent to 180 degrees on this side, and the little standard position array I drew for 150. So what's the difference between 180 and 150? That's 30. So that has to be a 30-degree angle there. So I drew these down here as a reference from what we did before with the unit circle. And since I have a 30-degree down there in the corner, we talked about having to use this triangle in the middle where it's got the 30-degree. So what this means is, this tells me my side measures. The hypotenuse is 1. The side along the axis is radical 3 over 2, but it's negative, since we're on the negative x side. And this short leg here measures a half. So then, in respect to the 30-degree, label OAH. 1's the hypotenuse. The side along the axis is adjacent, and then that leaves 1/2 to be the opposite. And since we're finding sine, you want to think about SOHCAHTOA. Which kind of combination am I? I need this combination. Sine, O divided by H. So 1/2 divided by 1, which is just simply going to be a half. Okay, let's try another one. 405. So I got to find standard position first. So subtract my 360, and I'm going to be at a 45-degree angle, which is in the first quadrant, and it actually splits it exactly in half. Not too shabby there. It's pretty good. So when I drop to make the reference triangle to find the cosine, I need to know the measure of this degree. And that's coming from 0 to 45. So the difference there, 45 degrees. Okay, so if I go back to that previous slide, so because I have a 45 degree, I'm going to go back to that previous slide, and I'm looking at this first triangle for my side measures. So both my legs are radical 2 over 2, and my hypotenuse is going to be a 1. So let's see. Side on the axis, radical 2 over 2, which is positive. Radical 2 over 2 positive here, and the hypotenuse is 1. So SOHCAHTOA, I need to label OAH. Hypotenuse is 1. Side on the axis is adjacent, so that leaves that height to be opposite. So then, let's see. I want cosine. So which combination am I going to be? I'm going to be this guy. A divided by H. So radical 2 over 2 divided by 1 is just going to stay radical 2 over 2. Maybe one more of these guys. 690, standard position. 690 minus 360, going full circle, would be 0, 3, 310 degrees. So, ooh, which quadrant does that put me in? 0 degrees, 90 degrees, 180, 270, back to 360, going full circle. Definitely in the fourth quadrant. 330 is between 270 and 360. And it's actually closer to 360, so let me draw this guy. There we go. Not too shabby there. Okay, raise my altitude to get my right triangle started. I need to know this angle happening at the origin, and that's coming from 360 and 330. So the difference between 360 to 330, that would be 30 degree there at the corner. So if I'm thinking about, the previous slide, again, I'm in this middle one for my side measures. Okay, so 1/2 radical 3 over 2. So on the axis will be my radical 3 over 2, and it's positive. On this opposite side here, it would be my 1/2, but it's negative because we're down in the negative y values. And my hypotenuse will be 1. So that's H. Side on the axis is A, and leaves the negative 1/2 to be opposite. So I'm finding, what am I finding this time? Let's see. SOHCAHTOA, I'm finding tangent. So what combination do I have? I've got this combination, O divided by A. So I'm going to write this one out. Negative 1/2 divided by radical 3 over 2. Okay, so I'm dividing fractions. I got to keep, change, flip. So I'm going to keep the first fraction, change to multiplication, and flip the second. And so then these guys cancel, and I'm left with negative 1 over radical 3. Only problem is, can't have a radical, so I gotta rationalize. Radical 3 over radical 3, I need to multiply by that. And so what's gonna happen? I'm gonna have, whoops, that's not what I wanted, silly goose. There we go. Negative, I'm gonna have radical 3 on the top, because 1 times radical 3 is just radical 3. In the denominator, square root of 3 times square root of 3 is square root of 9, which is simply a 3. Okay, so there would be my tangent value, negative radical 3 over 3. Okay, so if you got your trig packet, then I think there are 3 more. Those ones are for you to finish. So let's see what we've got coming up here. That's it for me. All right, so there's the next video that you might want to check out that we've got in our packet coming up. But that's it for this one, so keep learning, have fun, and I will see you next time.